Det är där de ser.
Okej. Då kör vi på det. Sådär. Nu ska vi se om jag hörs inte så mycket. Är det lagom? Ja. Det kan behövas. Ja, du vill ha tillbaka det, ja. Yes. All right, everyone. It's 1:15 and it's time to start. Today's lecture will be about graphical user interfaces in Java, where we will be working with JavaFX, which is quite fun. Yay. It's actually loads of fun. And the idea is that today we are going to get a little bit of history, GUI programming as such, but especially using Java, because Java has had quite a few iterations of how to create your own graphical user interfaces by now. And we will talk about the pros and cons and the ideas of these graphical user interfaces over time. But JavaFX, fairly new, but very well supported and way better than any previous attempt. But I want to give you some sort of introduction to this so that you understand where we come from, where we're going, how everything works, so to say. However, when we are done with the history part, and I'll try to move forward fairly quickly, we are going to program JavaFX, which is the main idea for today. And programming JavaFX is fun, fairly fast, and it's seriously good looking. However, if you like me, perhaps not being a designer, no framework in the world can help you. However, JavaFX does as much as it possibly can in order to make it possible, at least for you, to create something that's fairly good looking. What we are going to look at today are the basic concepts and the basic ways of handling the core concepts of JavaFX. And that means that we are going to look at, well, of course, a hello world example and a few simple things like effects. But we'll also look at drawing shapes. And there you will definitely see that I'm no kind of artist. We are going to look at responding to actions. So we want a button, but we want something to happen when we press the button, or whatever it might be. And we will look at something called layout and layout managers, which is the way to try to create a platform independent layout of your application. So that's really nice. That's really good. And we'll end this lecture by looking at a few of the controls that I find fairly interesting and fairly easy to start with. These being the text input, radio control buttons, and also images, because images are cool and you can use someone else's good images. And the next lecture I'm going to hold, we are going to go through loads of different other graphical components or widgets or whatever you would like to call them. And you will see that we can actually build a complete graphical user interface with JavaFX. All right, let's go on with a little bit of history. So today it's very common to use a graphical user interface, and it's been like this since the 80s. And we've had numerous kinds of GUIs. We've had Windows. We've had Windows 3. My first Windows was Windows 3.11, and it went downhill from there. Windows 95, 8, with these strange tiles, and then back to normal with 10. We have Mac OS, which had had quite a number of really nice graphical user interfaces, but now they have X. And then, of course, on the Linux platform, we know how to do stuff. So Motif, which isn't very beautiful, GTK+, KD, Qt, and so on. The idea here is not that you are not going to get a test at the end of this course for different graphical user interfaces and so on. But the idea is that looking from this, we see that there are a number of different ways to display things like text or buttons or menus and lists and so on. And as you all know, one of the core things with Java is that we want it to be platform independent. So we, in the end, want to create a graphical user interface once and then have it run on all of these different platforms. And that's not too easy, and that's why we are going to look at the history somewhat. Most of the ideas for the graphical user interface stems from Xerox PARC in the 70s. Xerox PARC was a really nice place where they invented, for example, Windows icons, menus, and pointers. They invented the laser printer. They invented object orientation. However, instead of commercializing all this stuff, they used bean bags and smoked stuff that you're not supposed to smoke. But the ideas were brilliant. And we get the basic GUI elements from that time, but we have, of course, refined them. For example, during this era of smartphones and tablets and so on. But the basic ideas are still the same. Then on to how we have programmed these. So from the beginning, we had a clear separation of the GUI code and the business logic. So the GUI code came from some other library that we used. So for example, in Windows and Motif and so on, someone created this using C, and then you could program something else like Pascal or whatever, and you used bindings to get everything working together. This meant that it was, problematic sometimes to get an interface up and running smoothly and looking good. Not the least because you could have a mix of different programming languages. For example, as I said, C programming in the libraries themselves, GUI libraries, and you could program something else, like for example an object-oriented language for your program, and therefore there was quite a lot of mismatch between how it was done in the library and in your programming platform. So just to show what it could be like, here's a 3-part example of getting a window up and running in Windows using the Win32 API and in C programming language. And this, again, is not something that you are going to get a test on, but just to show all the different stuff that's needed, like creating callbacks, creating the Win main with loads of cool stuff. And I mean this, oof. No, I have no idea either. And then you register these classes with which others, and then you, here, create window X. Sounds cool. The title of my window, loads of nulls. And then creation failed. That's not very nice. Show window, update window, and a message loop for just updating and getting input from mouse or keyboard or whatever. So quite a lot of code for just getting a window up with actually nothing in it. So now you're happy that you're not 42. Okay, but programming graphical language, programming graphical user interfaces today means that we are leaning more towards something that's better integrated with the environment that we are working with. So, for example, we have the Visual Studio and Visual Basic and so on for the Microsoft world. C++ Builder is a C++ equivalent, more or less, of what Visual Basic is. Qt Creator, Gambas, you name it. Stuff where we have a better integration between the programming language and the GUI toolkit that we're going to use. And Java has, from day one, has a standardized way of creating GUIs. Not always visually, but a way of creating GUIs. So this meant that they were really at the forefront of how to get this to work. However, the road to where we are today has been quite troublesome, really. There has been quite a lot of problems to solve to get to a state where we have something like today, a really solid solution. As I said in the beginning, from 95 and onwards, we've had this write once, run anywhere for graphical programs as well. But we started with something called the Abstract Window Toolkit. We then moved on to Swing, and then today we are heading into JavaFX, where JavaFX is the proposed standard for how to do it by Oracle. So there's no doubt on what we should use. But Abstract Window Toolkit, with the first release of Java, it was a really thin wrapper around the components that were available in the operating system or the graphical environment that it was running on. It was therefore called heavyweight components because it was heavily leaning onto what was already existing on the platform. The good thing with doing it like this is that you get a graphical user interface that looks exactly as everything else on that platform. So if you're running this program on a Windows machine, it will look like a Windows application. If you run it on a Mac computer, it will look like a Mac application. Problems? Yeah, quite a few actually. One thing, you could not always rely on there being exactly the same kind of components on all the different platforms. And you cannot rely upon the components that really were there to behave and look exactly the same in manners of where they were positioned, how much space they take, whatever should happen when you hoover them or wherever it might be. So the difference between a button on a Windows platform and a Mac platform is quite substantial. Add to that with every new version of the platform that you intend to run on, you need to recreate these graphical thin layer, so that it works with an updated version of Windows. For example, when we went from Windows 3 to 95 or from Mac OS 9 to OS 10 and so on, where the changes to the underlying platform were really great. So a lot of work and effort was needed by then Sun Microsystems to keep up with the changes in the underlying platform. And that doesn't give a lot of more resources to actually experiment and make new things. So they dropped this. Oh, sure. An example. Well, a frame here and a button ugly button at that. A text field in the middle. We set a title, a size, and then something strange with add center, add south for the different stuff. And this is from running on a Linux machine. So the window title bar is perhaps not what you expect. Other than that, fairly simple, fairly boring. So they understood that they couldn't really keep up with the AWT stuff. So they needed something new. So they invented Swing with Java 2 from '98. And in these components, they are, instead of being heavyweight, they are lightweight, meaning that the components are drawn by Java itself. So Java decides the size and the looks of a button, for example. So it draws all the stuff itself. And that means that it does not have to rely upon whatever changes are happening on the underlying platform. This, however, means that the user interface will look exactly the same on all platforms instead of looking exactly the same as all the other applications on each platform. And that meant that Java programs most often stood out. They looked different from all the normal programs, so to say. They had something called a pluggable look and feel, a theming support system, which meant that they could change the way it looks. So included with most distributions of Java was a Windows look and feel and a Mac look and feel and so on, as well as a number of other which, well, don't look anything else like anything else. The problem with the pluggable look and feel was that it was fairly hard to create anything that looked good, or rather the system itself, the pluggable look and feel system, was fairly complicated. But it made it possible to make something like this. This is the standard looks. And just in order to make it more fun, they changed the names of the classes to something with a J in front. So J frame, J button, J text field. The only one who would be really happy with this would be J.J. Abrams. Other than that, it looks fairly the same. Okay, so it sets up some bounds, visibility, adds north, south, and we also have a little slide over there, quite nice, and so on. And this steel look and feel, which was the default when it came out and for a long time, was, well, good looking for the time, however, quite ugly for today. But as I said, pluggable look and feel meant that we could do something like this. This is, as you can see over here, the Nimbus look and feel. Yay! Well, it was possible at least to change these so that they looked better than they did before. However, that was fairly difficult to do. So not that many themes, as we call them today, were available. Okay, so as you see, this was kind of a dead end as well. And also with all the problems that Sun Microsystems faced during this time, where they were eventually bought by Oracle, meant that they didn't really do very much with this stuff. But Oracle bought Sun Microsystems, and we thought, well, this will be the death of Java, but it wasn't. It really wasn't, because they found out something. They found out that there was something called JavaFX that Sun had created a few years earlier, which was really a scripting language for the web. It's not Java at all. at this stage, but there were some nice ideas. So they took these ideas and they ended the old JavaFX with version 1.3, and they created something new called JavaFX and JavaFX 2.0. And this version of JavaFX was announced at Java 1 in October 2011. At this time, I had programmed quite a lot in Java with Swing, and I heard a rumor that, well, they're going to propose something new. So I was yay happy, and I watched this Java 1 announcement, you know, streaming. I wasn't there because it was San Francisco. They don't pay me that good. So I streamed it, looked at it, and it was so beautiful. It was something completely different. Problem at the time, at this announcement, they published a version of JavaFX. However, that only ran on Windows, and I used Linux. So I actually, just for this, installed a virtual machine running Windows just to try out JavaFX. And it's so lovely. Today, JavaFX works on all major platforms. So it will run without problem on Linux, of course, Mac OS and Windows, yes. And you will also be able, with a little work, to get it to work on iOS and on Android. So it's quite possible to use Java now and JavaFX to push things to all those different platforms. It also works on Raspberry Pis and on Eagle boards and stuff like that. Quite nice. With Java 9, version 9 of JavaFX was released. However, the differences between the 8 and the 9 are really, really minor. Up until 8, there were actually quite a lot of differences. So with Java 7 update 44, I think it was, they did a lot of updates on JavaFX, or they released it there, and then they did a lot of updates. And with Java 8, they added quite a lot of new stuff. And for quite some time during the Java 8 lifetime, they actually made some major, non-breaking but major commits to JavaFX. But with 9, we're actually just fairly stable, which is nice, because you will probably use version 8. Okay, the good stuff. JavaFX is hardware accelerated. So if it finds a graphics card on your computer that it supports, that is via DirectX or OpenGL, it will support hardware acceleration, both 2D and 3D stuff on the screen. And that's quite nice. It has support for most audio and video formats, at least the important ones. It can display 3D graphics, but we will not look into that. But you can do loads of 3D stuff with JavaFX today as well. And it has 2 inbuilt themes, Caspian, which is the old one, and Modena, which is the new one, which is a lot of, it's more modern, as the name says. And if you want to create your own themes, this is fairly easily done today, as they've opted for using something that looks very similar to cascading style sheets, or CSS, which we know from the web world. So there are a lot more themes available, and it's a lot easier to theme your application today than it ever was. And apart from that, it contains all the usual suspects when it comes to GUI elements, like buttons, input fields, drop-down lists, dialogues, and so on. And they've also made it fairly easy to embed the old Swing stuff inside of JavaFX if you still need that. However, as we see, most of the stuff that we need to do today in JavaFX is quite possible. Yeah, so we are at a state where JavaFX is stable, it's really good, and you should really, really use it. Oracle has also stated quite clearly that they will not do any more development on Swing. Some support if there's something that's really, really serious, but other than that, you can mainly see Swing as something that's dead today. We want, of course, some sort of support in our development tools, like, for example, Eclipse. And all of the IDEs out there have quite some support for JavaFX today. I know that most of you use Eclipse, so if you do, also add this plugin. And I have no idea how to pronounce this. Eclipse, or something like that. Don't pronounce it, just install it. And you do that by going to the Eclipse marketplace and just install it. And that gives you tooling support so that it finds, for example, the correct auto-completion and stuff like that, and the right libraries, of course, for JavaFX. So with that, it's fairly easy to get up and running with JavaFX. And if you use any other IDE, there's equally good, at least, support in those as well. Something that I'm only going to mention is that there is a visual tool that's possible to use in order to construct your graphical user interfaces. It's called Scene Builder. From the beginning, it was released and updated by Oracle. Today, they've more or less handed that over to a company called Gluon. And that company also creates the bindings for Android and iOS. So they're really an interesting company to have a look at. You can go to this web page and you will see the Scene Builder, which they have with pre-compiled binaries for most platforms. It looks something like this. Yeah, so you can drag and drop different thingies to your window and create it. And you can populate it with good stuff like Star Wars, Pink Floyd, Roger Waters, David Gilmour, and over here's a button for Doctor Who as well, and a nice slider. We are not going to use this tool because we want you to be able to program it first, so that you understand the concept, the basics, and so on of it. However, when you do, please have a look at this tool as well, because it really helps in creating graphical user interfaces. But you need to know the basics first. And there are actually a few different ways of programming. The reason for this tool being in existence at all is that it is possible to construct your user interface using XML, or as they call it, FXML, because it's way cooler. But it's basically XML, and that's exactly what Scene Builder or other similar tools, if they will ever show up, will produce. So these tools will produce an FXML file which you read into your Java code, and then you can create controller classes and so on to respond to different behaviors. And the good idea and the reason behind this is that you want to give this Scene Builder to someone who can actually design a user interface so that someone can use it, and then they hand over this usable user interface to you or any other programmer, and you make the business logic behind it instead. So clear separation between concerns. All right, let's go on, and we will in just a few seconds see our first example. But first, the main concepts. A JavaFX application is hierarchical, so it's a tree structure, and they use a few different concept words, one would say. They call it the theater metaphor, because we see everything as a theater, and on this theater there is a stage. These stages can change. If you've been to the theater, they sometimes change this stage, and that's exactly what we do as well. We have a theater, but we have stages onto it, and we switch, if we like, between stages. And on these stages we have nodes, which are these little people over here. And these nodes are everything graphical that we actually see. Like, for example, buttons or lists or drop-down lists or whatever it might be. Images, of course. So all of these are put onto the scene, which is part of the stage. The stage being this, and the theater being all of this. You'll find out soon enough. So first example, of course, it will be Hello World. It will be a application where we put these words, and they will not be Hello World. They will be something else. But we will put these on the window with exact coordinates, which isn't the way to do it. The way to do it is to use layout managers. And we are going to look at that today as well, and it's not that difficult. It's actually so much easier than it was in Swing. They've introduced 2 layout managers that make life so much easier than it ever was in Swing. But you will also notice that the main method in a JavaFX program does really nothing more than call the start method. And it's even the case that the main method, the normal main method in Java is only used as a fallback, because this is going to extend application, and everything should work without a main method. It's using the start method to get going. All right. The next slide will show some code. Are you ready for this? Well, the sound effects were mine. All right. Public class, this one's called JavaFX lecture, extends application. So everything extends application when it's an JavaFX application. Here we have the start method, and it will give us a primary stage as the input, and it does this from the beginning. So when you use a template, like in Eclipse, for example, you will get this start method, and you will get this main method, which merely calls launch in application and starts. So all the cool things are done here. And this is a fairly simple yet interesting example. So we create a text, and look here, they've skipped the J's. So now text is text again. However, if you use Eclipse or whatever tool you're using, and sometimes they want to complete the code for you, and they want to make imports automatically and so on. From time to time, the IDE will prioritize the AWT version of things like, well, perhaps not text, but label, for example, and button and so on. So just have a look and see to that the import are these JavaFX libraries. Okay. So text, new text, X and Y position, and then a string with the text itself. And as I said, it's going to be tree structure of it. So we create a root. In this case, we're going to use something called a group, which is something that just groups panes together, and this is a pane. So for root, we call this get children, and we add text, meaning that we have a root and we add the text node to that root. After that, we create the scene itself. You remember that we wanted to have something to look at, a scene. The scene takes this root and it has a size in pixels. Now we have a scene consisting of a layout using this root containing just one little node, namely the text one. However, that's not enough. We need to put this on a stage as well. And we have a stage, the primary stage over here. So we use that. We set a title for the primary stage. We set a scene for the primary state, which is this one, sorry. And then we show it. And that's basically how it works. And we're going to look at loads more examples of how to do this, so fear not. It will look something like this. And again, I'm using GNOME shell on a Linux machine, so therefore this toolbar will look exactly as it does on my computer. But other than that, this text here will look as you would expect on your computer. So the quote, "Any sufficiently advanced technology is indistinguishable from magic," is by whom? Someone? You're an illiterate bunch? Arthur C. Clarke. Oh yeah, you're supposed to say now. This is actually in text format what I've already said, so I'm not going through this again. We'll look at more examples. So, just to clarify, we have a stage which is this entire window. So if we want an application which opens many windows, we create many stages. We get this primary stage when the application is constructed. However, we can of course create our own stages as well. We have a scene, which is this part, the visible part inside of the window. In this one, in this simple example, we have this group which basically consists of the entire scene. And in this group, we have a text node. Both group and text are nodes, but they are not nodes from the same level, as we'll see in just a second. Each stage can contain many scenes, and each scene can contain many nodes, and they will contain many nodes. This simple example isn't really realistic, but we'll see more examples soon. And this diagram shows parts of how this works, and we have the important stage and scene classes over here, where we can see that a stage consists of it should be one or more scenes, and the scene consists of parent, which is a node. However, it's a subclass of node, meaning that it has to be something of control or pane in order to be placed on the scene. We saw, for example, text previously on the last slide, which is also a node. However, it is not a parent. So we cannot place a simple node directly onto a stage, but we need something that inherits from parent first onto the scene. And that's why we have a number of different layout managers in parent. All of this will be very clear when we get further. So to show more examples, first off, all nodes in JavaFX are seen as vector graphics. That means that we can add effects to them and visual properties to these nodes. This is for the fun of it, but also in order to make it easy to make things that look really good, if you know how to do that. So all nodes can have these effects. So even if a node is a bitmap image, like a JPEG or PNG or something like that, we can decorate them with effects. And there are a number of them. And we're just going to look at an example of doing that. We have the same text class as before, but I've changed the text. And yes, I'm going to ask you in a little while who said that. So I also set a font for this one. And then I created drop shadow, which is one of the different effects. I set an offset in X and Y, and I set a color with a transparency, like here. And then I set the effect for this text. I create a root, which is of type group, add text to it, and I create the rest just as I did before. And this is a simple way of just adding some. Now you can hardly see, but there's a there's a shadow behind this text. It's really nice over here. Yes?
What happens if you use a font someone else doesn't have?
Then it falls back to some default. Most I would guess a normal sans serif font. All right. Okay, who said that? I do not fear computers, I fear the lack of them. Yeah, thank you. Isaac Asimov, the other great sci-fi author. Yeah, smartphones are nice. All right. Before we go to a break, I will show you how to draw some shapes so that you have something to laugh at the break. And it is possible using JavaFX to draw simple and complex 2D shapes. And it's also possible to draw 3D shapes, but that's outside the scope of this course, so we will not do that. The positioning, as with the text one, is that we have 0, 0 up in the left corner. And then there are a bunch of line, rectangle, circle, arc, and so on, with numerous different attributes, and we have position, size, stroking, filling, and so on for all of these. Here's an example that I've done myself, and that will become very obvious in just a short while. I create a circle here, which I call cockpit, which is a circle with the coordinates 320, 240, and 50 in radius. I set it to a black stroke with a width of 10 pixels, and I don't fill it, so it will not be filled. Then I create a line, something. Here's a start position and the end position, and a stroke with that one, another one, and a bunch of lines. Here's something cool, a polygon. Get positions, and I go from that position to that one, all of these. Left cannon, and I can see you draw. What is it? What is it? Yeah. And you see that all of these different things that I draw are objects of different classes. So when I'm done with the drawing itself, I call root get children add all, and then in the order that I want to add them, I add cockpit, connector 1, connector 2, left wing, right wing, and so on. And when that's done, I create the scene and the title and so on. The title says it all, right? It's a TIE fighter. Yeah, 3.5 hours. You laugh. But I did it myself, so I will have it up here while we take a break so that you can look through the window. We'll continue again in, say, 10 minutes.
Vi är lika dåliga. Vad sa du? På teknikkonvention fick vi båda det. Ja, men det förtjänar verkligen. Jag tycker det. Det är min idé. Jag tror han är... Alltså, först skrev jag typ allting på en dag. Sen, ja, sen typ så här... Jag bara flyttar runt texten till slut. Men jag skrev, du vet, typ en presentation, då skrev jag färdigt allt. Och jag ändrar ingenting till det slut. Nej, jag bara flyttar runt texten. Typ satte det på olika ställen. Sen skrev en till rad på. Va? Fick du av? Ja. Ja, men det är ju för att du fick av på latex-grejerna. Det är inte bara en. Det är därför vi fick se. För vi fick B på latex-grejerna. Jag tycker det är så klagar. Vi fick B på våra båtar. Precis.
All right then. Let's try to continue. All right. Quite nice, quite easy, fairly easy at least to draw if you know what to draw and so on. And if you've had a look at the assignments, you'll see that one of your assignments is to draw a little snowman, and it's very easy, however very complicated at the same time. This is the extent of what I can manage. All right, however, just looking at stuff isn't that much fun. We also want a graphical user interface that we can interact with. So we want to be able to respond to events. And anything that we interact with, for example, buttons, menu selections, selecting something in a list and so on, all of these things are events that we should respond to. And we do this using event handlers, and I'll talk more about that in the next lecture. This lecture we will merely just work with them. And in Java, a great many of the different components or widgets or controls has this set on action method, which we use in order to bind a action to a event, for example, clicking. And as we'll see, we can do this using either, because what we have there is one single interface called handle, and we can implement this using either lambdas or the old traditional way. And we have this old traditional way because Java 7 was the first version with JavaFX. And it wasn't the first version of Java 7 at that, so and therefore they didn't have lambdas in Java 7. And the reason why I say this is that you will, when you search the internet for examples and so on, you will from time to time see an example using the old style of event handler. However, it's much easier to do it the lambda way. Also notice, and you'll see this when we declare things that we want to change inside of a such method, it needs to be final, or we can put it as a field in our class, and that's because JavaFX wants us to be certain that we have an object to which we put a value. It doesn't matter what value, but the variable itself or the object itself must exist. So, responding to an action is either this old way or this short and sweet way. In this one, we can see actually what's happening. It's this is a button object, and we uses its set on action, define that as a new event handler for an action event where we override the handle method, putting an action event into it. In this case, we just print out hello world in the console. In Java 8, we can reduce this to this button set on action event and this fun little arrow in lambdas, and then curly brackets like this and inside. And that's because we only have one single method that we need to implement. We can shorten event to just E if we like. It's so many letters to type. I mean.
So event is like the object, or
Sorry?
event is the object, or
Well, in this, yeah, it's actually an object of action event. And in the next lecture, we are going to look a little bit more on what we can do with that object, because we can read that as well. But we know that this is what we need to implement, and therefore lambdas gives us this shortcut of doing it. But it's the same object, yes. So, in this case, we will have a button called change text. And this button will change the text on a text called the text. And it does that by adding to the set on action, and you see a E, short, sweet. If the text doesn't equal shine on your crazy diamond, we set it to just that. Otherwise, may the force be with you. So a button which we press repeatedly and see shine on your crazy diamond, or may the force be with you. And that's all we need. As I said, I would use this Java 8 way of doing it. However, you will see a lot of the old style as well. Okay, a slightly extended from the previous example. We we can use the primary set title over here if we like. We have the text, which is just text, and we put it as final because we want to use it down here. And then we have some fun font stuff and a drop shadow, and then our button, and this is just the text that's going to be on the button. On action, just as you saw before, notice here that we need to add both the button and the text for this to work. If we forget to add the button, well, it will not show. And then up with it. Great. It doesn't get much better than this. So yeah. However, even if the message over here is really great and important, it does look like, yeah. So, what can we do when we have a great many components that we want to have on our window? Well, we use layouts or layout managers to define how these different components are going to be positioned on our screen. And layout managers has been something that's been with Java and GUIs from really day one. And it's a way for us to define the behavior of different components rather than the exact positioning. So we define that we want to have, for example, 3 components horizontally. And in the old days, that was really important, because if the buttons or these things, let's say there are 3 buttons, if they have different sizes on different platforms, well, if we have exact positioning, they will overlap, or there will be too great a distance and so on. So therefore, we just define the behavior of the layout using many different of these layout managers. In JavaFX, we call them panes with this spelling. In Swing it was pains. And these work by stretching the layout, as I said, to fit the best possible layout with some manual things you might need to do from time to time. And let's go for this, because these layout managers, they are classes which we instantiate as objects as well. And the two really most useful, I'd say, which you can solve most problems with, are the V-box and H-box for vertical or horizontal box. It defines a box in either direction into which we can put different nodes. And these nodes can be other layout managers. So we can have layout managers in layout managers in layout managers. And we'll see this in just a second. And when we do that, there are a number of methods we can use to define the relation between the different things, both inside and outside the layout manager itself. So for example, the set padding defines the spacing that we want outside of this layout manager. But if we want to control the space between the different components or the different controls inside the layout manager, we use the set spacing instead. We can also use something called set pref size to define that a button should be this wide instead of it trying to adjust to a 4K screen or something like that. But you'll see. So this is without layout managers. In this example, we use label, which is basically like text, but not really. For example, we cannot position it manually. So we need to use a layout manager to get it to look good. Because we create 3 labels like here with Star Wars, Doctor Who, and Pink Floyd. We use group as previously, which is one of the simplest of layout managers because it just groups stuff together. And we add all of these 3 to the root layout. And you see, that's not quite nice. That's ugly even for me. So let's make this a lot better then. I create these 3 labels again, but I also create these labels. So now we have 6 pieces of text that we want to display on screen. I use V-box, vertical box, like this. And I set some padding. It uses the insets here, which can be 5 on each side, or you can define top, bottom, left, right. Spacing, however, is just a double defining how much space we want around the different components inside of a layout. But this will be our new root. And then inside of this one, I will be using a horizontal box as well, called horizontally, with a new padding, a new spacing, and I add the Star Wars, Doctor Who, and Pink Floyd text or labels to that one. And then a V-box, an additional V-box called vertically, where I insert Blade Runner, DC's Legends of Tomorrow, and One instead, these labels. And then to this root, which will position things vertically, I add horizontally, and I add vertically. As I have on the outermost place, I have the root which is vertical. That means that horizontally will be placed over there, and below that, vertically will be placed. Hopefully. Yeah, it did. So over here, horizontally showing the different labels, and over here, it will show it vertically instead. And by combining these, we can define almost any kind of user interface. And I'd say that the addition of VBox and HBox has made positioning in Java so much simpler than it ever was before. However, there are a great many more panes, yeah, I know, that you can use. So, for example, there's one just called pane, which makes it possible for us to better define where we want to have stuff exactly. There's grid pane, which we are going to see in the next example, which positions things in a grid. The anchor pane, which positions things in relation more directly to other things. And there's stack pane, which positions things above each other, on top of, I should say, and so on. And here's a link to more about layouts in the layout tutorial from Oracle, and it's actually quite good. From time to time, I'd say that the Oracle tutorials can be a bit dry. However, the JavaFX stuff that they've done is really, really nice. So I recommend that you have a look at them. So let's have a look at grid pane, because that's a great way to position things in a grid. And the example that we are going to look at is something that looks like a login control for an application. And that means that we want to create a user interface where we have rows and columns. And they are indexed from 0 and up, of course. An alignment can be set for these panes in different ways. We use add with 2 indexes, yeah, something like that. The first one is for the column, and the second for the row. And the good thing here is that we do not need to define the grid before we use it. So the more we add, the larger the grid will be. So it will actually be exactly as we define it, instead of, like, for example, arrays where we need to define a size before using it. So this one is more dynamic. And in this example, we will also see another few controls. I call this one login. I create a grid pane. I set the alignment to position center, meaning that they will be centered in the specific cells. Otherwise, they will, yeah, not look too good. I set padding, and it looks like I know exactly what I do because there are point values. But yeah, it looks good. Something that we can also set is the H gap and V gap for horizontal and vertical gap. So we can define the gap vertically and horizontally between the different cells in this grid. And then I repeatedly create, we call this grid pane. So pane add a new label, because the label we don't need to reference later on. A new label called username, and I position that at 0, 0, like this. So it will be the first one to the left. And then I have a final text field, and text field is something that we can type into. Call that one username, a new text field like this. And then I add this one to column 1, row 0. So it will be one further in. And I need to do it like this because I need to reference username further down here. And I do the same for password. And then we have a result, which is just if we are going to be able to log in or not. And then I have a button. And this button I add to this position, column 1 and 2, row 2, sorry. And then test login has a right position. So I position everything to the right. That means that this button will be to the right instead of the normal to the left, but you'll see that in the slide next. And then an on action. In this case, it's fairly simple because you need to have a username Charles Clements, and Pink Floyd is the password. You should do it more safe than this, I think. But this is just for show. It will look something like this when we start it up. And this looks good, doesn't it? Yeah? Yes, great. We have username and we have a nice size here of this one. When we see, and this is something that I find really, really important, namely that the different components are aligned correctly. So we see that we have an alignment line over here and another alignment line over here, and we see that all of these align over here. And those things are really important to make a user interface that looks good or even great, in contrast to something that just looks like something you've done yourself. So that's really important. If I try to enter something, Gene Urso, and I have no idea what I put over there, and I press login, it will say no way over here, because here we have that result label. But if I enter Charles Clements with the password Pink Floyd, it will say okay. So this illustrates, I'd say, something a bit more professional or good looking than the previous ones. And then, of course, you can combine this with all the different layout managers. So say, for example, that you want a text above username and password with something like login in bold and stuff like that. Well, create a VBox, create the label, and put the label in the VBox, and then put this grid pane into that VBox as well. So both of them, and it will adjust accordingly. So quite easy to build up these. Okay, so oops. I will now show you a few more controls, and the control selection or component selection or widget selection that I've made is just enough for you to get through the first assignment in this, and they just touch upon the bare necessities and the bare essentials on this. But the first assignment contains 3, in a way, not very difficult tasks, though the last one can take a bit of a time. And the next lecture we will fill up with a great many more controls than these. And I would also like to point out that there are a great many other controls available via third parties, like for example something called Controls FX, which has a host of different components that you can use just by adding that jar. And even though we are going to have one more lecture, we are not going to be able to look at all the different controls that are available. So have a look at the documentation. For example, this Java SE Client Technologies has a lot on the different components that are available. And there's also something called the Internet, where you can search stuff and you will find information there as well. All right. We've already seen text input, and I didn't mention it, but if we go back to this one, we see that this password field is not the same as the text field. So when we use this password field, we see that we get these bullets instead. And that's because all of the text input field, text input classes, they inherit from this text input, and then they add different behavior. And it's also the case that we can actually use some of these inside of other classes. So we can create table classes. There's a few table classes or rather list classes where we can say, well, we want text field to be included in this so that we can make lists and make them editable and so on. And these text fields, they use, or any text input, they have this set and get text, but also for managing the global clipboard, copy, cut, paste, and select all, and so on, that we can use. So on any platform that you are running this, you can use copy, for example, to copy the text that's in a text field to the global clipboard, for example. Here's a Swedish example. So those of you who can't speak Swedish, here's something to learn. Kopiera. It means copy. It's not that difficult. And here it says kopiera again. So I didn't have time to I didn't prioritize to change the name of a single button. What it does is that you put something in this text field over here, and you press kopiera, and it shows up on the other side in a label. And even though we actually know exactly how this works by now, but this is an example program that I try to create for every new toolkit that I want to use. If I know how to create this program, I know that I can solve most problems using that toolkit. And that's not always that simple. However, what I don't show in this is how this one behaves if I change the size of it. But I'll leave that up to you. So what does it do? Well, it creates a left text field, and it creates a label to the right, and it creates a button, and in this button, oh, look over here. I've already translated kopiera to you. Don't say that on the exam later on. I want to kopiera, my friend, because you're not allowed to. On this set on action, adjust kopiera, whatever is on the left to the right. That's the only thing that you're going to remember from this lecture, kopiera. I create this as a horizontal box. So I make some insets and some spacing, and then I just add them left button right like this. And then create a scene. And look over here. Yeah, I translated it again. Quite simple, but we want to see more good stuff. So we take a leap and we look at radio and check buttons with toggles instead. So in many user interfaces, we want the user to be able to select from different categories or whatever it might be. And these radio buttons and checkboxes, they are quite similar, but the radio buttons, they just allow you to choose one alternative from a number, while the checkbox allows you to tick a number of options. Okay. This means that we want to use something which in JavaFX is called a toggle group, especially for the radio buttons, because we want to make sure that only the one in this specific group should be selected. And then when we want to read if a checkbox or a radio button is selected, we have this is selected, which we can use. It's possible to add listeners, event handlers, and stuff like that, so that something happens exactly the second when you select something. However, that's not very good behavior, so therefore you should just read this is selected. We are going to make a pizza maker. And for some reason I actually had pizza today. We are going to have a root layout which is a vertical box. And as you see, we set all the usual stuff. We create a label which is heading. And this label is Pizza Maker Mega Ultra Plus using the font Conforta 42. Okay. After that, I am going to create the different buttons. And for pizza, we are going to select either, we are going to select a kind of crust, and we are going to select some kind of topping on our pizza. So we have a new vertical box for the crust, and with a label, choose your crust, and then the radio buttons, radio button deep and radio button thin for deep pan pizza or thin and crispy pizza. And you can only choose either one of these, because you can only have one crust. Otherwise, it becomes a hamburger, and that's something else. In order for us to make certain that just one choice is made, we create this toggle group. And we say that deep should be in this toggle group, and thin should be in this toggle group. So we connect them like that. And that means that we can only choose one of these. If we choose the other one will be unselected. The first one will be unselected. And this box crust, get children, add all, label crust, deep and thin, like this. So we add this. And then we want to do the same with toppings, but you can have more than one thing on your topping. So therefore, we are going to use checkbox instead. Olives, new checkbox olives like this, anchovies, pineapple, mushrooms, and so on. And then box topping, which is also a V box. We just add the label first, and olives, anchovies, pineapple, mushrooms like this. As we can choose many toppings, we don't need a toggle box. We also want our button, and we put that below the things that we've done before, because we also want a answer string or a label with what we've chosen, because this is not a very elegant program. So we have a order over here, which is a string builder or a string. So when we press the button, order, which is our button over here, set on action, we go through the different alternatives. And we have an if, else if over here, because either deep or thin is selected. Either one of these must be selected. And then we need to check olives is selected, then append olives, anchovies, pineapple, mushrooms, and so on. And then we set this answer, which is this one, to the order. The box order contains the order and the answer. The layout, which we saw on the other one, has the heading, which is the overall heading, the box crust, the topping, the box topping, and the box order. So we have, as you can see, layout in layout in layout to get something that looks this good. All right, so you can choose deep pan, thin or crispy. And here you can also see that JavaFX uses lightweight components, because they've created their own skin. This is Modena. So it doesn't really look exactly as it does on your platform, whatever it might be, but it looks like a JavaFX program. However, it does look quite good, and if you are not satisfied, there are CSS files to download and use for Windows or for Mac OS and so on. But I'd say it looks quite nice. Thin and crispy, olives and anchovies, I can't eat those. They are horrible. So pineapple mushrooms, yay! And then I press place order, and it says that I've ordered thin and crispy pizza with pineapple mushrooms. Are you discussing pizzas? Yeah, that's good. Yeah, as long as I am in charge of your grades, it's a good thing. All right, so this looks a bit better than what we did before. And these are the things that you need to know right now, except for one thing, images. Images are fun. There are other people who can actually draw things that look like things that you recognize. And you can take photos and so on. And that's exactly what we're going to look at here. In JavaFX, we have support for the most common file formats, I'd say. JPEG, PNG, GIF, and BMP. No support, unfortunately, for vector graphics as such. So no SVG, PS, or something similar to that. But these bitmap formats, at least. Displaying an image is done in 2 steps because we have quite good control over our images. We have something called an image viewer, which displays and changes the image in whatever way we want. And we also have an object that holds the image itself. And this is because we want perhaps this image to be used in different places, and we want different effects or things to be made on these images. So the image view is kind of a viewport onto this image. One problem is most often where to place these different images, and that depends. It's the default class path for the project, which is usually somewhere above where the sources are, but it depends on your IDE. You can also place an exact path to them, but that's ugly. But you can. Over here, me in the morning, Monday morning outfit. Yeah, you don't want to know. All right. So what this one does is we use the class image, which points to the image itself. And over here, you need to find either where the class path is. It's a good idea to create a folder in that class path called images or something like that and put it inside of that. But other than that, it's just the name of the image itself. And then we have an image view, which helps us to view the image, and we set what image we want to use. In this case, I just want to show this image. So therefore, I'm finished there. I create a group, I get the children, and I add the image view. Notice here that I need to add the image view. I cannot add the image itself. I must use the image view. And then the normal scene, stage, and so on. And when I run this program, it looks something like this, or exactly like this, if I have this image. And it's a little bit better, perhaps, than my TIE Fighter. All right. When looking on internet for inspiration, there might be something else that you see when it comes to images, namely something called resources. And images can be handled by as resources, and then you put them basically in the same place, and you read them with something like this instead. So get class, get resource as a stream tags. Some people prefer that, some people prefer the other way, but you see quite a lot of both ways of doing it when you search the internet. So therefore, I just want you to know that this is another way, using reflection instead, that's possible to use. But when we have our image, we can do much more with it than just this. We can change the size of it. We can define, for example, width and height for it. we can also use this set preserve ratio, so we can change the width, for example, and then we set preserve to true, and it will make it look good. So it will scale it, basically. We can also define a viewport, so which part we would like to take from this image, different parts, many parts, and so on. And for each part that we want to pop out, we can have a single, each of them will be a single image view. And we can rotate, smooth, loads of stuff with this. And I'll just show you an example. This is my home. This is the original image. And over here, I've taken a viewport by making this image view. I've taken a part of it, cut it out, and rotated it slightly. And that's the idea for having this image view, because I load the image itself and then I create a view. This view, I say it should fit a view, a width of 300 and have a preserve ratio to true. So it will be 300 wide. But I will not take the entire image, but I will rather start at 200, the pixel X 200 and Y 100, and then I will go 100 in each direction, meaning that I will take something that's smaller than 300, but I want to fit this 100 by 100 into 300, so it will stretch it, and that's what we see here. This one is it's stretched, but it's still correct ratio. And I also, when I define this rectangle which we are using here, I also set this viewport to this rectangle and use rotate 45 degrees to get the little rotation. And you can of course do much more with this than just that. But it's fairly simple to do. That is what you need to know. But before I leave you, or you leave me, yeah, we leave each other, I would like to show you a few more things that you can have a look at. There are a few demo programs that are available on the Oracle download site for JavaFX. So you can get, today JavaFX is included of course in the JDK, so you get it if you download JDK. But these downloads over here are, for example, Ensemble and Moderna, and both of these showcase much of what's possible in JavaFX. So to get a glimpse of what's to come in the next lecture, but also because we won't have time to look at everything, you should have a look at these programs and see what's possible to do. Both of these programs, Ensemble and Moderna, are provided with source code, so you can have a look at it and see how it's done, and you can do that too. So just two screenshots for showing. First, Ensemble, which has a little nifty menu over there. You press and you get this menu, and you can show, you can choose by clicking over here. And all of this is of course the Ensemble application, so you can search for different demos, because it has loads of demos of loads of stuff that you can do. And you can see a few of them over here, and there's something cool over there. Back and forth between the different demos that you've been looking at, with a lot of source code available in the program itself, but also the entire application available for looking at. And to see the Moderna theme, you can use the Moderna application, where you can see here, for example, radio buttons and checkboxes, tabs, buttons, a menu, and loads of these stuff we are going to look at in the next lecture. But if you just want to go in and have a look at what's possible, charts, for example. We are going to look at that. HTML editor. Well, it's so gorgeous, so I don't know where to start. So just have a look at it to see what's possible. And I will show you the details of quite a few of these controls the next time. However, now I just have one more thing to say to you, and that's Copiera. See you next time. Thank you for today. Yeah.
So I just install the yeah Eclipse Fix.
Yeah. Oh, I have no idea.
And it's still doesn't work. I think it's a class.
Yeah, and you're in somewhere. Yeah.
Yeah, but it's just the.
No, that's not the right one.
Yeah. Just this way. No other things.
Okay. Can I?
Okay.
Because I usually, yeah, if you take that one, and I think you can on the JavaFX.
Yeah.
Best to start with the JavaFX
Project.
But you should also be able to have. That one.
Oh, okay.
Let's test. But why does it access restriction?
So it's the build path.